as I'm looking at this question, I'm thinking, well, I know about the series of 1 over 3 to the n. I know what happens with that. So I'll say this. Let's compare this series with the series as n goes from 1 to infinity of 1 over 3 to the n. Because that one is, what kind of a series? It's geometric. I could write this as the sum as n goes from 1 to infinity of 1/3 to the n. It is a geometric series. And r equals 1/3. So r is between -1 and 1. So this series does what? Converges. And now I'll put a little bit about that. This series converges because it is a geometric series with r equal 1/3. So it's between -1 and 1.
Should there be a -1 in the first, on the solution? The 1 over 3n?
No. When I say this series,
Okay.
I'm talking about this one.
The dominant, okay.
Right. So this is the one I know about. And so we're trying to figure out the one that was written there. So you're gonna pull, but you're solving one series, you gotta pull another one out that you know about. So I have that, and then I'm looking at this, and in my head I'm thinking, do I have the inequality? Or am I gonna have to use limit comparison tests? Let me write that. That's not necessarily something you would write, but I want to write it because it's something you should think about. So I have A sub n is the one I'm trying to figure out, and then B sub n, the sequence, is my 1 over 3 to the n. Inequality-wise, how do they fit together? Which one's bigger? A sub n's bigger. Because A sub n, the denominator is a little bit smaller, which means the fraction's bigger, right? Yeah, okay. So I have this. With A sub n greater than or equal to B sub n. So I know series B sub n converges. If the one I'm looking at, term for term, is bigger, I cannot use the first comparison test. But I can go with the limit comparison test. So I'll put, let's use the limit comparison test. Because this inequality does not fit the comparison test. Now, I've written that here, but that is not something you would need to write on your test paper. Because, but those are things you should probably think about when you're solving this problem. So, for the limit comparison test, I need to find this. I need to find the limit as n approaches infinity of A sub n over B sub n, and that's the limit as n approaches infinity of 1 over 3 to the n minus 1 over 1 over 3 to the n. And I'm going to write this, the limit as n approaches infinity. Well, this is division of two fractions. Oh, and that should be a regular minus 1 divided by 1 over 3 to the n. So to divide fractions, take the second one, flip it over. So that's 1 over 3 to the n minus 1 times 3 to the n over 1. So this reduces, that's the limit as n approaches infinity of 3 to the n over 3 to the n minus 1. Now that limit is going to what number? That's going to 1. Now some of you have come to my office, we've talked about this, and do you need to show any work? Last semester, you probably did something like this. You probably did 1 over 3 to the n over 1 over 3 to the n multiplied by the dominant term in the denominator, the reciprocal of the dominant term in the denominator. That's the limit as n approaches infinity. That would be 1 over 1 minus 1 over 3 to the n. And this top fraction's going to 1. This one's going to, fraction, the top number's going to 1, the numerator. This is going to 1, this is going to 0. It's going to 1. That is a finite number, and it is greater than 0. So both series do the same thing. And I know that the one I pulled out my toolbox converges. So I know that the one we're looking at, I'm going to write by the limit comparison test, series n goes from 1 to infinity of 1 over 3 to the n minus 1 also converges. When you take a test on this material, it's not just converge or diverge. It is how do you know what's happening. If you're using a series you know about, you need to tell us what that is. And I want to know what test you use, limit comparison test, in this problem.